Hello, in this video we will use SERIESSUM LINEST in the polynomial regression of the power series dataset. We'll generate the power series dataset using our formula of A times B to the power B. So here we have y equals A times bx to the power B. We'll show that in the chart. That equation will be in the chart using trend line. So we have power series, and this is our equation. It confirms that our equation for this trend line is y equals 3 times x to the power 3. Our value for A is 3, and the value for B is 3. But we will use the polynomial. We'll use polynomial, and we'll calculate these coefficients of the polynomial equation. So we begin with the filling up the x matrix. So we have y equals 108 minus 172x plus 45x squared. So the coefficient for b0 is 108. The coefficient b1 is negative 172, and the coefficient b2 is 45. We'll calculate this using the matrix and Linus. So begin with filling up the x column, which is the one column, which is our formula, the x values to the power 0, and that's the one column. And we have the x column, our formula of the x values to the power 1, and that's the x column. And the x squared column, which is our formula of the x values to the power 2, and the x squared. Now that we have completed the 1x matrix, so we have y equals 108 x squared. We have the x column, the x column, the x to the 0 column, the 1 column, the x column, and the x squared column. We can now calculate the LINEST. So we have LINEST of data y. This time we use the x column, x and x squared column, data x, and we show the full statistics. So here we have the 12 outputs. We'll calculate all these 12 outputs using the matrix. But first, we take a look at the value b0. Our b0 matches to our equation. Our b1, negative 171.6, is rounded off as negative 172. And b2 is 45, matches to our equation. We can calculate this value using the matrix. So we use the Pijarina inverse, which is m mul inverse m mul transpose of this matrix and itself. And we calculate the Pijarina cofactor, which is m mul transpose of this matrix and the y values. Now we can calculate the coefficients b0, b1, and b2, which is m mul of this Pijarina inverse and the Pijarina cofactor. So our b0 matches to our b0 in the LINEST and the equation. Our b1, negative 171, matches to our LINEST, but is rounded off in the equation, in the trend line equation. And our b2, 45, matches to our LINEST output and also our trend line equation. Now we can calculate for the estimated y, or y hat, which is a mult of the 1x matrix and the coefficients. We can also use series sum, which is our formula, series sum of these x values, and our power starts from 0. The power of starts from 0 and increments by 1, and the coefficients b1 and b2 and b2, b0, b1, and b2. And our values for estimated y and the series sum are the same. Next, we'll calculate the rest of the outputs of the line nest. We start with the rows. So we have we since we already have the y hat and the y values, so we can use this the RSS, the zero sum of squares. Sum x, sum of squares, or difference of y and y hat. Y hat can be series sum or the estimated y. They're the same. That's 55,598 matches to our Linus output. And calculate for the population, which is rows of the range 11. Then we calculate for the degrees of freedom, which is rows minus columns of the range of the range. That's 8 matches to our Linus output. Now we can calculate for the stay x, which is equal to square root of RSS, residual sum of squares, divided by degrees of freedom of the denominator. That's 83.365 matches to our Linus output. Next, we calculate for the standard error values of B0, which is stay x times square root of P0 1. 63.51 matches to our Linus output. And standard error value of B1, which is stay x times square root of P0 2. 29.549 matches to our Linus output. And the standard error value of B2, which is stay x times square root of P0 3. That's 2.846 matches to our Linus output. Next, we calculate for the total sum of squares, which is m times variance of population y. Now we can calculate for the regression sum of squares, which is TSS minus residual sum of squares. So this is our regression sum of squares. Now we can calculate for the F statistics, which is equal to regression sum of squares divided by 2, because there are dependent variable, two independent variables, so two values of x, divided by stay x squared. Stay x to the power 2. That's matches to our F statistic matches to our Linus output, while our ESS matches to our Linus output. Next, we calculate for the R square, which is equal to ESS divided by, that's regression sum of squares divided by total sum of squares. And it's 0.9946 matches to our Linus output. And also our chart. If we show the R square value of our chart. So our chart is 0.995, which is rounded off from our R squared. This completes uh, the use of series and line nest in the polynomial regression of a power